Okay, so since we made it all the way through the review on Friday, I wanted to just work some of the problems that I thought might give you some difficulty, and I added 2 problems on top of the review problems that I wanted to go over. So this is number 5 on page 501. This is that review that we did, the mid-chapter quiz that we did in class one day. It says scientists at NASA drop objects from tall towers to study weightlessness. An object is dropped from a tower that is 24.1 meters high. Use the equation D equals 4.9 t squared, where D is the distance in meters that an object falls in t seconds, to find to the nearest tenth of a second the time it takes the object to reach the ground. Okay, so they told us that it was being dropped from a tower that's 24.1 meters. So we fill that in for D, and we set that equal to 4.9 t squared. To solve for t, we're going to have to divide both sides by 4.9. And I wanted to show you kind of a little shortcut here. We're going to have 24.1 divided by 4.9 equals t squared, right? And so we can just take the square root of both sides. So instead of dividing this out and then taking the square root, one shortcut on your calculator is to take the square root of the actual problem here. So 24.1 divided by 4.9. Now you want to put the division problem in parentheses so that you take the square root of the whole thing. If you don't put it in parentheses, it'll take the square root of 24.1 and divide that answer by 4.9. But you want the square root of the whole division problem. So if you hit equals here, it's going to give you a simplified version here of this, but you don't want something with a radical. We want to round it to the nearest tenth, so I'm going to hit shift and then the equal sign again, and I get 2.217. Now this problem asked us to round to the nearest tenth of a second. That would be this digit right here. We look one digit to the right, it's a 1, so 4 or less, let it rest. Our answer for t is t equals 2.2 seconds. All right, then I wanted to work for you on page 507, a good word problem for using midpoint. And this problem says the center of a circle is equally distanced from all points on the circle. Consider a circle with center C and a segment that has endpoints at A is -2, -1, and B is 6, 5. And it says those points are on the circle. The segment passes through point C. Find the coordinates of point C. So point C is equally distant from both of these points. We're going to use the midpoint formula. And if you remember the midpoint formula, it says x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that gives us the coordinate, or the ordered pair of the coordinate for the midpoint. And so let's do x1 plus x2, -2 plus 6, -2 plus 6 divided by 2. That's 4 divided by 2, which equals 2. So our x coordinate is 2. And then we'll do this one, -1 plus 5 divided by 2. That equals 4 divided by 2, which is 2. So our ordered pair for that point is 2, 2. So that's what C equals. All right, now I'm going to flip over here and I'm going to work a few problems from the review that we did. And that review actually started on page, I'm still trying to get there, sorry about that. Starts on page, we started actually on page 528, but since we did a midpoint problem here, I would like for us to start with actually the tangent ratio. And so they have a triangle, and we all know I'm not very good at drawing, so bear with me here. This is a right angle. This angle is 20 degrees. we have 48 here, and then we're looking for this. All right, so this is actually the example problem in that review. And so we know the adjacent is 48. This is 20 degrees. And we're looking for the opposite. So we know we're going to use the tangent. So we say tangent of 20 degrees equals, opposite is m, adjacent is 48. So when we put this in our calculator, we say tangent 20 degrees equals. Okay, we're going to get this number, and we can actually write this number down, but I want you to leave it in your calculator because you're going to get a more accurate answer if you'll actually use what they give you on the calculator. So I'm going to write 0.36397 equals m over 48. I'm going to multiply both sides by 48. These will cross out, so I'm going to be left with just m here. I'm going to multiply this side by 48. And when I do that, I'm just going to multiply what I have here times 48. And my answer is 17.47. They want us to round to the nearest tenth. And so here's our tenths place. We look at the next digit to the right. It's a 7, so 5 or more raise the score, so our answer is 17.5. Okay, so if we look at number 32, just below that, it says in words. We don't have a diagram this time, it just gives you a word problem. It says in triangle PQR with right angle at R, angle P has a measure of 72 degrees. So the measure of angle P is 72 degrees. It says the leg adjacent to angle P has a length of 8 units. Find the length of the leg opposite of P, angle P, to the nearest tenth. So again, we're using opposite over adjacent. So tangent 72 degrees equals x over, and they said that the adjacent has a length of 8 units. So here we go, back to our calculator. We're going to say tangent 72 degrees equals, okay, this is 3.07768 equals x over 8. Remember, I'm going to leave this in my calculator. I'm going to multiply both sides by 8 so I can solve for x. These are going to cancel out, and I'll get x equals, I've left this in my calculator so I can just multiply times 8. And my answer is 24.6 because the digit next to the 6 is a 2, so I let it rest. So x equals 24.6, but remember in the problem it says that the length of the adjacent side has a length of 8 units, so they actually want us to use units as our label. So there's our answer for number 32. Number 33, this is an example of sine or cosine. It says find the value of b in triangle ABC round to the nearest tenth. I'm going to have to show you a picture of that, so let me move my book over here. And because it's the teacher's book, you're also going to see the answer, but this is the problem we're working. We're going to find the value of b in triangle ABC. We know this one, and we know the hypotenuse. So this is adjacent over hypotenuse. That's going to be cosine, because remember cosine equals adjacent over hypotenuse. So to do number 33, we need the cosine of 40 degrees equals adjacent, which we don't know, over 15, which is the hypotenuse. So here's our calculator. We're going to do cosine 40 degrees equals, okay, so that gives us this answer, and again, we can write this down and set it equal here, but I'm going to leave that in my calculator. And when I multiply by 15 on both sides, these are going to cancel out, so I'll get b equals 15 times the cosine of 40 degrees. So I'm just going to put times 15 in my calculator equals, and it's 11.49. It wants us to round to the nearest tenth, so B equals 11.5, and that is our answer for number 33 on page 529. Now I'm going over to the chapter test section of our review, and we've done a midpoint. Let's do the distance formula. So get a clean sheet of paper here, and if you turned in your book to page 530, I'm going to actually work number 19. It says find the distance between the points -6, -2, and -2, 1. Now the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so when we do this one, this is my x2, y2, this is my x1, y1. So I'm just going to plug my numbers in. So D equals the square root of -2 minus -6 squared plus 1 minus -2 squared. All right, this is like -2 plus 6, so we end up with 4 squared is 16 plus, this is like 1 plus 2, which is 3, squared is 9. So the distance equals the square root of 25. And we're going to get a positive number because you can't have a negative distance. So distance equals 5 on that problem. All right, so that was number 19 on page 530. Let's do number 20 on page 530. And I'm actually going to try to show you the diagram and the problem, and then I'll work through it real quick. So I'll have to move my camera just a little bit here. And we're doing this problem. You can see the answer, but let's work through it. Many boats have a lightning protection system that includes a mast or other metal pole extending above the vessel. The pole and all the larger metal parts of the boat are connected to form a path along which electricity can be conducted to the water. This system forms a cone of protection extending 60 degrees around the tip of the pole. How far does the cone extend from the mast at water level? And that's the distance DC in the diagram. Give your answer to the nearest foot. Okay, so we know that this angle is 60 degrees, and we know that the distance here from D to B, or the height of that pole, is 35 feet. So we are looking for this distance. We know adjacent, we're looking for opposite, so we are going to use the tangent. All right, so here we go. Move my book out of the way. Okay, so this is number 20. We're going to have tangent of 60 degrees equals opposite, which we don't know, that's what we're looking for, over 35. So we get our calculator again, and we do tangent 60 equals, and that says the square root of 3. I'm going to put it in decimal form. All right, so this is 1.7321 equals x over 35. If we multiply both sides by 35, we're going to get 60.621. Okay, it wants it to the nearest foot. So we're rounding at the ones place. We look one digit to the right, it's a 6. So 5 or more raise the score. And so our answer for X is 61 feet. All right, so that's our answer for number 20. I'm going to also do number 21 and number 22 really quick, and I'll read these to you, but let me draw the diagram for you. It's just a triangle. Again, excuse my crude drawing here. This is C, B, A. Angle A is 65 degrees. And we know that the measure here, the adjacent to angle A, is 8. They want us in number 21 to find the value of A to the nearest tenth. And then in 22, they want us to find the value of angle C to the nearest tenth. All right, so for number 21, we're doing opposite over adjacent. And so that's tangent. And so it's tangent over, or tangent of 65 degrees equals A over 8. So if we do this one, we just say tangent 65 equals, all right, so it's 2.1445 equals A over 8, multiply both sides by 8. So we're just going to multiply that by 8. And we find out that A equals 17.156. It wants it rounded to the nearest tenth, so it would be 17.2. All right. Now, for the next problem, it wants us to find C. Okay, so we now know that this is 17.2 and this is 8. This time we're going to work with adjacent over hypotenuse. So in order to do this problem, we do adjacent over hypotenuse is cosine. I almost wrote tangent again. So cosine of 65 degrees equals adjacent over hypotenuse. All right, so work with me here for just a minute. We're not solving this time by just multiplying both sides by a number. This time, if we multiply both sides by a number, or by the h, let's multiply this by h also, then these are going to cross out, and I'm going to get hypotenuse times the cosine of 65 degrees equals 8. But I don't want this, I want just h. So if I divide by the cosine of 65 degrees on both sides, these cross out, and I get h equals 8 divided by the cosine of 65 degrees. All right, so now we are at a place where we can just punch this into the calculator. So we want 8 divided by, open your parentheses, cosine of 65 degrees, close your parentheses, close that parentheses, equals 18.92. They want it rounded to the nearest tenth, so our answer is h equals 18.9. All right, so those are the few problems that I thought might give you trouble. I will be in my classroom during third hour tomorrow if you have any other questions or want to catch me during lunch. Have a good evening. I'll see you tomorrow.